Okay, in this lecture we're going to talk about finding the the slope of a linear function and using the slope to actually graph the linear function. In this case we're given an equation of the linear function of y equals 5 on 2x minus 5. Now we use the intercepts like our usual practice, and we do that by finding first of all the y-intercept, and that is found by finding when x is equal to 0. So if that's the case, we have y is equal to 5 halves by 0 minus 5, which of course is negative 5. So our point is 0, negative 5. Alright, so that's this point right here. Right, now the x-axis intercept, right, is when y equals 0. So this, when x is equal to, y is equal to 0, so we have 5 on 2 x minus 5 equals 0. So we have 5 on 2 x equals 5, which implies, of course, that 5x equals 10 or x equals 2. So our point would in fact be 2, 0. So right here. So the line we're talking about is in fact this line here. Now we'd like to look at the slope of this, okay, and see how that relates to this particular graph. So if we look at the slope, we have 2 points now. Notice we have 2 points here. So the slope is actually given by y2 minus y1 over x2 minus x1. So let's take this one as our x2, y2, and this one is our x1, y1. So we're going to have 0, subtract negative 5 over 2, subtract 0, which of course is 5 over 2, which is interesting because this is in fact 5 over 2. Alright, so what this is saying is that for every time we go across 2, 1, 2, we go up 5. 1, 2, 3, 4, 5, and there it is. And so really what we can do to draw this graph is we can look at what the slope is, okay? Determine the y-intercepts, work out the slope, alright, and we only really need 1 point, and if we had 0, negative 5, which is here, then we can say, well, the slope is 5 over 2, so every time I go across 2, I go up 5, and bingo, there's our point, and away we go to draw it. Okay. Alright, let's look at the second example. We have a line passing through the point negative 2, negative 3, so that's this point here. Now based on what we did in the first example, notice that we have a slope of 4 over 3. Now remember that this is equal to the rise over the run. So every time we go across 3, we need to go up 4. So here's 1, 2, 3. So there's the 3. Now we're going up 4. 1, 2, 3, 4. There's my point. And there is my line. Okay, which is the line going through negative 2, negative 3, having a slope of 4/3. Now the thing to keep in mind, remember, is that whenever I have a slope that is rising to the right, this is a positive slope. Whenever it's going down to the right, this is a negative slope. Whenever it's just horizontal, all right, of course we're going to have a slope of 0. Okay, and whenever we have a vertical line like so, then the slope is undefined. Now another thing to keep in mind is if it's a positive slope, all right, then it's rising to the right, and that implies then that we have an increasing function. Right? If we have a negative slope, this will imply a decreasing function. All right, now another thing about the slope is this. The slope, right, remember, is what it's doing is it's telling us that it's the ratio of the vertical change, that's the which is the rise, okay, vertical change, which is the rise in y, in the y variable, all right, to the horizontal change. Which of course is the run in the x direction. So in other words, the slope actually is the average rate of change in y per change in x. Okay. All right. So per unit change. All right, in x. So in other words, our average rate of change is equal to, all right, and let's say it's on a interval, closed interval, say between a and b, right, is equal to the function value at b, that's y2, minus the function value at a, which is y1, over b minus a. And so this is the average rate of change, which is determined by the slope. And so the slope of a linear function is actually giving us an average rate of change. And that allows us to find average rates of change when we have linear models.